Okay, here we go. So let's take a look at some of these questions here. So number one, a book series has 7 volumes numbered from 1 to 7. The number of ways in which these books can be placed on a shelf so that some or all of the books are out of order, of increasing order. So we're saying that if they're going in decreasing order, that's still considered out of order, is, well, what? Well, there are 7 factorial ways that the books themselves can be organized. And there's only one way in which they're actually in increasing order. So of those 7 factorial, we're going to just get rid of the one way that isn't in order. Okay? And so that would be the answer that you're looking for that question. Okay, for this next question here, it says the number of 13 letter words formed from the letters of the word possibilities, okay, with, and then I'm going to give you a bunch of restrictions here. Now, first of all, bear in mind here that we've got 3 S's. Okay, S's, and we've got 1, 2, 3, we got 4 I's. Okay, so that's going to become an issue here. Now, how many ways can we permute those with no restrictions? Well, in the numerator, we treat them all as if they're different. So it's going to be 13 factorial over 3 factorial, 4 factorial for the repeated S's and the repeated I's. And that's because this isn't a restriction. Okay, when I do this, it's not because there's a restriction here. That's just what happens when they're identical letters in there. What if each word starting and ending with an S? Okay, well, first of all, because of the repetition, I know that I'm going to divide by 3 factorial and 4 factorial. Now, to start with an S, I've got 3 S's to choose from, so just going to be 3. And then at the end, I got to end with an S, so there's going to be 2 other S's to choose from. Once I've grabbed those 2, it turns out there are 11 letters left over, and I don't really care how those are permuted. So I'm just going to put 11 factorial in there. So it's going to be 3 times 11 factorial times 2 over 3 factorial, 4 factorial. If we want the I's not all together, well, okay, not all together, that's a difficult one to do if you try to build it up from scratch here. So what we're going to do is we're going to take all possible permutations, which we calculated at the beginning in A, and I'm going to subtract all the ways that the I's can be together. Now, if you treat the I's as if they're together, okay, so that's I, one little group here. And then we've got P, O, S, S, B, L, T, E, S, okay. Then there are 4 factorial ways I can permute the I's. Okay, and this is still going to be over 3 factorial, 4 factorial, so you can see some canceling here. And then I've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10 objects that I would then permute on top of that. Now let's take a look at the next one. It says the B and the E together. Now, if we treat the B and the E together, basically we're doing something similar to what happened up here. It's just that instead of having 4 letters together, we're only going to have the 2 letters together. So we still have the repetition of 3 factorial and 4 factorial. But in this case here, the B and the E together form one group. And so that would be 1. And then if you include that with all the others, that's going to actually leave you with 12 different objects here. So if you just want to see that, if you have the B and the E together, then it's going to be P, O, S, S, I, B, already got that, I, L, T, I, E, S. So then we've got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. Oops, am I missing something? Oh, I'm sorry. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11. No, I am missing something. Possible. I-B-I-L-I. Oh, I forgot the T. That's what's going on here. So there's got to be 12 there. Now, but the B and the E do not have to necessarily be in that order, and that's the issue right here. Whoops, that's the issue right here, is they just got to be together, so there's 2 ways they could order that. Now, the next question is B and E are together and in that order. Well, in that case, then what happens here is you don't get that option of having the 2 factorial down there. So these 2 questions are related, just that this one is going to be a little bit smaller because we're limiting the number of options there. Now, if the P, B, and T are in that order, once again, we've got 3 factorial, 4 factorial. If the P, B, and T are in that order, in other words, let's just think about it like this way. How many ways could you organize P, B, T? Like, it doesn't matter where they're located in there. Just how many ways can you order it? How many ways can, P, B, T, could it be PBT, PTB, TBP, whatever, and so on. There's going to be 6 ways of doing that, or 3 factorial. So if I just want them to be in one order, doesn't matter where they're located, just one order, then what I want to do is I want to divide out all of the possibilities that exist no matter where they're located. Okay, because let's say you've got PBT as the first 3 letters there. Well, there's then 3 factorial ways those could be organized. Or what if PBT is like first, middle, and last letter? Well, then there's 6 ways that those could be organized, or 3 factorial. So what happens here is out of the 13 factorial ways you could organize all of those letters, I'm going to divide out the 3 factorial ways that you could permute the PB and the T. Now, you should notice here that that's very similar to treating them as if it was PPP. And if you actually think back to that example that we used to develop this idea, like the word to, TWO and TOO, yeah, actually that's very, very similar. That's like saying that OW in that example have to be in that order. Okay? Now, what if you've got 2 I's at the beginning? Well, once again, 3 factorial, 4 factorial for the repetition. I've got 4 I's to choose from, and then I've got 3 I's after that. And then after you've chosen those, there's still 11 letters left over that I have to permute, and I don't really care, so I'm just going to leave it 11 factorial. But if you've got exactly 2 I's at the beginning, that means I've got to choose one of the 4 I's, then one of the 3 I's. Still got to take into account that repetition. So there's the I's there. But now what I got to do here is I got to throw a letter on there that's not an I. And it turns out there are 9 letters left over that aren't I's there. So that now just those first 2 are I's. Then after that I can put the rest of the letters down in whatever order I want, and there's 10 factorial ways I could do that. Okay, so in this question here it says Elizabeth has 3 nickels, 3 quarters, 2 loonies in her pocket. The number of different sums of money that she can form using one or more of these coins is, well, when she looks at the nickels here, it turns out she's actually got 4 options that she can choose from. Okay, she could choose 1 nickel, 2 nickels, 3 nickels, or no nickels. Okay, 4 options here. Same thing for the quarters. No quarters, 1 quarter, 2 quarter, 3 quarters. For the loonie, there's going to be 3 options. Now, if we assume that she has to be pulling money out of her pocket, then we're going to subtract the 1 option where I chose no nickels, no quarters, no loonies, and get rid of that possibility that exists in this set of options that we're looking at. Jason tuned into the hockey game halfway through the 3rd period. The score at the moment was Oilers 5, Flames 2. Okay, that's because we're in Edmonton. The number of different possible scores for the end of the 2nd period is, well, okay, the Oilers have 5 points right now, but it could have started at 0, 1, 2, 3, 4, 5. So there's actually 6 possibilities for them. For the Flames, it could have been 0, 1, 2, which leaves them with 3 possibilities. Okay, so that's what we're looking at with that question right there. It's hard here though because you're seeing those 2 numbers right there, but those are just the ones that we count, right? It's very hard sometimes to include the number 0 as those possibilities. So this question says, a system of roads built in a small town form a grid. The town has 4 blocks running north and south and 6 blocks running east and west. Okay, 4 blocks running north and south. So there's a street, there's 1 block, 2 block, 3 block, 4 block. Okay, 1, 2, 3, 4. 6 blocks running east and west. There's a street, 1 block, 2 block, 3 block, 4 block, 5 block, 6 block. Okay, and so now to go from here to here, remember that's going to be east, 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 east. So that's 1, 2, 3, 4, 5, 6. And then south, 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 1, 2, 3, 4. So there are 10 line segments that we got to travel total here, and there's repetition. Okay, 4 S's and 6 E's. Okay, now let's take a look at some of these pathway problems. So to go from A to B, I've got to go east, 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 east. That's 1, 2, 3, 4, 5, 6, 7. And then I've got to go south, 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 south. That's 4. Any pathway that goes from A to B has got to go east 7 times and south 4 times. So that is going to be, altogether, it's going to be 11 factorial over 7 factorial, 4 factorial. Over here, I've got this in-between point here, C, so this is going to be east, 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 south, 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 south. So that's 1, 2, 3, then 1, 2, 3, 4, so it's going to be 7 factorial over 3 factorial, 4 factorial. And then I have to multiply that because this is an AND thing. I have to do them together. So this has got to be E, 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 E. So 1, 2, 3, 4, 5, 1, 2, south, south. So 7 factorial over 5 factorial, 2 factorial. Okay, that's how we'll figure out that one. Over here, for this one right here, to go from A to B, it's going to be going east, 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 north, north, up, 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 up. So 1, 2, 3, 4, 5, 6, 7, 8, 9, 10. So that's 10 factorial over 3 factorial, 2 factorial, 5 factorial. Okay, so for this one here, we have a group of 6 Canadians and 8 Americans. The number of groups of 4 that can be formed. Well, I haven't given you any kind of indication as to how it's supposed to be broken up. So I've got 14 people there, and I just need 4. So just 14, choose 4. How many that will have at most 3 Canadians? Okay, well, to have at most 3 Canadians means you could have no Canadians up to 3 Canadians. So that would mean that I have a committee that's all Americans, okay? And I had to have a committee of 4 there. I had to work that in there. Multiplied by 6, choose none. Or, there's the addition, 8, choose 3 times 6, choose 1. Or 8, choose 2 times 6, choose 2. Or 8, choose 3 times, 8, choose 1 is what I want to do. Is I want it to go smaller here. 8, choose 1 times 6, choose 3. And then I'm done. That's my at most 3 Canadians. Now this one here, so of 7, groups of 7 that can be formed if neither Alex nor Bob can be selected, but Diane must be selected. Okay? Now, this one here is there, just to see how you're reading this question here. Are these guys Americans, Canadians? What it doesn't say, right? But that doesn't matter because now we're just talking about groups of people. So I've got 14 people to choose from. Essentially what I've got here is I've got a group of 2 people and I can't choose either person. And then I've got 1 person very specifically that I must choose. Now that's 3 people total out of 14. So that leaves me with 11 people left over, and I'm going to have to choose 6 of them to be in this committee here. Now actually I think I might have keyed that one wrong now that I'm looking at it on the quiz there. So I'm going to go fix that one there in a few moments here. How about of groups of one or more? Okay, well, groups of 1 or more, that's going to be, it's going to be a weird one. It's going to be 14 choose 1 plus 14 choose 2 plus ... up to 14 choose 14. Yikes. However, there is a bit of a shortcut here. And we haven't explicitly looked at that yet, okay? But if you've kind of looked over the material and looked in the workbook there a little bit more closely, you're going to see that the shortcut here is actually to go 2 to the 14 minus 14 choose 0. If you were to put a 14 choose 0 plus 14 choose 1 all the way up, that would end up being 2 to the 14. So the answer here is going to be the difference between them. However, most people are just going to end up doing something like this anyway, because it's easier to work through. You can see it. Okay, you can see what's happening. You can see each committee along the way here. How about of 6, groups of 6 with more Canadians than Americans? Okay, well, if it's got to be more Canadians than Americans, that means we could have all Canadians and no Americans, or 5 Canadians and 1 American, or 4 Canadians and 2 Americans. And you know what? That's where you got to stop, because as soon as you go less than that, then you've got equal numbers there. Okay, so that's the number of ways that can happen here. A group of 6 with 4 Canadians and 2 Americans. Well, that's a nice one here. And so sometimes what happens is you get these nice ones that kind of pop out, and people make them out to be harder than they are here. That's just going to be 6 choose 4 times 8 choose 2. That's it. Okay. How about of 6 with at least 3 Americans. Okay, so with at least 3 Americans, that could be 3 Canadians and 3 Americans, or 2 Canadians and 4 Americans, or 1 Canadian and 5 Americans, or no Canadians and 6 Americans. There's really no other shortcut for that you can take here. How about this one here? Of 6 that can be formed if Anne and Barbara cannot both be selected. Now, you could select one of them, okay? You could select one of them, in which case, of the 12 people left over, you'd have to choose 5. Or, actually, you don't have to choose either one of them, and then from the remaining 12, I should say, you would have to choose all 6. Or groups of 6 that can be formed if Amanda or Bill must be selected. So one of those must be selected, in which case 12 choose 5, or you could choose them both. Okay? And that is sometimes an option that people forget here. When we use the word or in math, it is used in the inclusive sense. It could be one or the other or both. So that's going to be a tough one for people to kind of get their heads wrapped around here. How about of at least 2 people that have equal numbers of Canadians and Americans? Okay, of at least 2 people. So that could be 6 choose 1 and 8 choose 1, or 6 choose 2 times 8 choose 2, or 6 choose 3 times 8 choose 3, or 6 choose 4 times 8 choose 4, or 6 choose 5 times 8 choose 5, or 6 choose 6 times 8 choose 6. And that is about as far as I can go with that one, because if I go any further, then I won't have equal numbers here. That's a big one. And that's how you would handle those problems.